All right, algebra. We're going to do parallel and perpendicular lines. Our objective, I did type it out. Determine if two lines are parallel or perpendicular, as well as write linear equations for parallel and perpendicular lines if we're given slope and a point or 2 points, etc., etc. All the stuff we've done kind of coming down to this. All right, let's get to it. All right, so what are we looking for? Well, first, let's discuss parallel lines. And these lines are parallel, but how do we know that for sure? I mean, it looks like they're going in the same direction. And what does parallel really mean? Well, if lines are parallel, they're lines that never intersect, which is another way of saying they never cross. They're on the same plane and they never intersect. So let's take a look at this blue line here. What's the slope of this blue line? Well, let's use our slope formula, which you guys should know very well by now. 0 minus 6 divided by 2 minus 0. That gives me negative 6 over 2, which is negative 3. Right, so I'm going down 1, 2, 3, 4, 5, 6, and over 2. That makes sense. So our slope is negative 3. Let's take a look at this red line. Let's just count. What's our slope? I go down 1, 2, 3, 4, 5, 6. So that's negative 6. I go over 1, 2. My run is 2. That's also negative 3. What about this green line? Down 1, 2, 3, 4, 5. And then I go over 1, 2. Oh, so this green line is down 5 over 2. Did I count that right? 1, 2, 3, 4, 5. This one is not parallel. So K1 is parallel to K2. Why is that? Because they have the same slope. That means for every right movement of the x, I'm going to have the same amount of downward movement in blue as I do on the red line, okay? Their slopes are the same. Parallel lines have the same slope. Well, so then what do perpendicular lines look like? Well, let's look at perpendicular lines. Here we have two lines. We have this line here that goes through point T, and then we have this line here, which goes through point, I guess we'll call it 3, 0, and also 0, 2, okay? And it looks like the red line, the red equation goes through the point 0, negative 1, okay? So if we look at these equations, let's write the red one in red. I have y equals 3 over 2x minus 1. And then the blue equation, I'm going to write in blue, y equals negative 2/3 x plus 2. Well, so their slopes are clearly not equal. 3 over 2 does not equal negative 2/3. So we know for sure they're not parallel. But what does perpendicular mean? I have this little square here. It means they intersect at a 90-degree angle. But let's look at the slopes. If the slopes told us something about parallel lines, maybe it can tell us something about perpendicular lines. So I'm going to look at these two slopes. And I have, just wrote them already, 3 over 2 and 2 over 3. What I notice is that the numbers are in different spots. So in the red equation, I have 3 over 2. In the blue equation, I have 2 over 3. What do we call that when we flip a fraction? Anybody know? It's your time, you should be yelling it out loud. It's the reciprocal. Okay, and what do we notice here? In the blue, I have a negative. In the red, there's no negative sign. So these are opposites. They're opposites. So when two lines are perpendicular, their slopes are opposite reciprocals. I'm going to write it so it makes sense here. Opposite reciprocals, meaning I take the slope, 3 over 2, I throw a negative sign in front of it, and then I flip it, 2 over 3, negative. And that's what I get here. So if two lines are perpendicular, their slopes are going to be opposite reciprocals. Well, what if we only have equations? In the last one, we had y equals, was it 3 over 2x? And then I'm just going to write they both go to the origin. How's that sound? And we had y equals negative 2/3 x. For parallel lines, y equals 2x plus 1 is going to be parallel with y equals 2x plus 2. Y equals 4. What just happened here? 4 over 2x plus 1 is not parallel to this one. It's the same equation. And that is something a little different. So don't fall into that trap. Just because the slopes are the same doesn't mean they're parallel. It could be the same exact line. But these two are parallel, right? Slope is the same, and then we have a different y-intercept. Okay? If they're not in, if you have one equation that's in point-slope form, and one equation that is in slope-intercept form, to tell if they are parallel or perpendicular, we're just looking at the slope right here. Okay, we have to solve to make sure that they're not the same line. We want to avoid this situation, right? So comparing, you're going to get questions like this. Write the equation of the line that satisfies these conditions. So there's some line, it goes through 0.42, and it's parallel to this line here. Well, what's the slope of this line? It's going to be this guy right here. Negative 3/4 is my slope. So the slope of the line we're looking for, because it's parallel, is also negative 3/4. So I have a slope, I have a point. We're going to use point slope. I wrote it backwards. We're going to use point slope formula. And then we're going to solve to put it into slope intercept form. So let's do that quickly. I have y minus 2 equals negative 3/4 times x minus 4. First, let's distribute our slope into the parentheses. So I'm going to rewrite y minus 2 equals negative 3/4 times x plus negative times a negative is a positive 3. Let's add 2. I'm going to add 2 to both sides so I can get the y alone. And I get y equals negative 3/4 x plus 5. So you see the slope is the same and the y-intercept is different. So this y equals negative 3/4 x plus 5 is the equation of the line that satisfies the condition that it goes through 0.42 and is parallel to the equation y equals negative 3/4 x minus 5. Well, let's write the equation of a line that satisfies the following conditions. It goes through that same point 0.42, but now it's perpendicular to this line, 3 over 2 times x minus 5. Forgive the formatting here. Sorry about that. So we want the same thing, perpendicular. First thing we're going to do, oops, sorry about that. I'm erasing stuff. Didn't mean to. First thing we're going to do is we're going to look at the slope right there, okay? So our slope equals 3 over 2. What is the slope for the line that's going to be perpendicular? So this symbol right here, this means perpendicular, this means parallel, okay? It's going to be the opposite of 3 over 2, which is negative 3 over 2, and then the reciprocal, which is negative 2/3. That's what I'm going to write here. So I'm looking for a line that has a slope negative 2/3, and then it goes through this point. We're going to use our friend point slope formula. That was poor grammar. We're going to use our friend the point slope formula, and we're going to solve, because we want to write our equation in the slope-intercept form. So I have y minus 2 equals negative 2/3 times x minus 4. So first thing I'm going to do is I'm going to distribute, okay? So I'm going to rewrite y minus 2 equals, and I get negative 2/3 times x plus 8/3, right? Negative 2/3 times negative 4 is positive 8/3. I'm going to add 2 to both sides. That's going to give me y equals negative 2/3 x plus, well, let's take this and add it. 8/3 plus 2 over 1. I need a common denominator, so it's going to be 8/3 plus 6 over 3, which is 14/3. This is our answer. So if you look, if you see our slope here, negative 2/3, that's what we wanted to find. That was the slope of the line we're looking for, because it's the opposite reciprocal of the slope we started with. And here's our y-intercept. So to recap, parallel lines have equal slopes, right? perpendicular lines, perpendicular, that's a tough word to spell over and over, have slopes that are opposite reciprocals. Whoops, cows. Okay. Your practice for this assignment is going to be found on page 81 of the book. You're going to do number 11. You're going to do 15 through 26, and you're going to do 30. Doesn't seem like a lot, but by now, the new skill is just identifying which lines are parallel and which lines are perpendicular. If you have any questions, you know how to get a hold of me. I hope this helps. Good luck.